Okay, welcome to our Pumpman quiz, proudly sponsored by Pumpman, suppliers of industrial, commercial, and domestic pumps, suppliers of wholesale priced centrifugal pumps, submersible dewatering pumps, irrigation and garden pumps, bore pumps, and many more. Speed drives. So contact Pumpman for all your pumping needs. Now, let's quickly proceed to our quiz. This is a question from November 2023, paper 1. This was question number 4 and is based on exponential functions. We are given p of x is equals to 1 over 3 to the power of x. What did we say? We said when the base of your exponent is greater than 0 but less than 1, then you are going to get a decreasing function with a shape like this. Right? All together, this will be our p of x. Please, I refer you to our tutorial on exponential and logarithmic function to get more details on this. If your function is having values of x increasing while values of y are decreasing, then it means it's a decreasing function. In other words, if you were to draw a tangent on the curve of the graph and the tangent is slanting to the left, then it means it is a decreasing function. So you were supposed to just write decreasing function, then you get your 1 mark like that, right? So you get your 1 mark like that. Then 4.1.2, you are supposed to come up with the inverse of p. What we know, our p of x is the y, so what we do, we interchange positions of x and y, meaning to say x is equals to 1 over 3 to the power of y. Then we go on to make y the subject of a formula. Y is equal to log to base of 1 over 3 of x. So you get 1 mark for that and 1 mark for that, and then you get your 2 marks like that. Now 4.1.3, we are supposed to write down the domain of the inverse of p. Very simple. If you look at the graph of p of x, which we have just sketched here, you realize that its domain is x is a real number and the range is y is a real number, y is greater than 0. Meaning to say, the domain of my inverse is, I put x where y is going to be x is a real number, x is greater than 0. Right? So my domain is going to be x is a real number, x is greater than 0. Right? That is going to be my domain of the inverse. Now, the line of asymptote, the asymptote for p of x minus 5. What is our asymptote for p of x, so that we can use transformations to answer this question? Very simple. Our p of x, the line of asymptote is the line of y is equals to 0, the x-axis. It does not touch or cross the line of y is equals to 0. So that is our asymptote. Now when we say p of x minus 5, it means we are shifting the graph of p of x by 5 units downwards with its line of asymptote, meaning to say my asymptote is going to move from y is equals to 0 to y is equals to minus 5 after moving it by 5 units downwards. So therefore, my line of asymptote is going to be y is equals to minus 5. Then you get your 1 mark like that. That is my line of asymptote. 4.2, we are given f of x is equals to 4 over x minus 1 plus 2. That is a hyperbolic function. So remember, from your basic function graph, the graph of y is equals to a over x. What is your value of a here? Is 4. So the graph of y is equals to 4 over x, we know, is a graph that is lying in quadrants that are defined by asymptotes. Y is equals to 0, the x-axis, and x is equals to 0, the y-axis, right? So this is my graph. In my head already, I've got an image of my basic function graph so that I can be in a position to tell what happened for me to determine the transformations that map my basic function graph onto my graph or my function of f of x. Now, your graph of y is equals to 4 over x will be like this in the first and the third quadrants, like that, with your axis as the asymptotes. What is the difference between y is equals to 4 over x and y is equals to 4 over x minus 1 plus 2? We are subtracting 1 from x, which causes the graph to shift, this graph to shift by 1 unit to the right. And we are adding 2 to the entire function, which causes this graph to shift by 2 units upwards. Meaning to say, my lines of asymptotes are going to move with the graph from x is equals to 0 to x is equals to 1. No wonder I wrote here, my asymptotes, vertical asymptote is x is equals to 1. What about my horizontal asymptote? Is going to move with the graph from the line of y is equals to 0 to the line of y is equals to 2, right? No wonder I'm saying my horizontal asymptote is the line of y is equals to 2. So my asymptotes, x is equals to 1, y is equals to 2. Those are the equations, and you get your 2 marks, like that. Now we are asked to determine the x-intercept. What do we know? At the x-intercept, we know that y is equals to 0. So we are going to substitute for f of x, which is our y, with 0. And then what we get, 0 is equals to 4 over x minus 1 plus 2. We go on to make x the subject of the formula. So for x, we get our x is equals to minus 1. And then we write it as a set of coordinates like that. Which means, therefore, my x-intercept is minus 1, 0. Okay, let's move on to 4.2.3. We are asked to sketch this graph. For us to sketch any graph, we need to know the x-intercept, which we have already determined from the previous question, but we do not have the y-intercept. How do we calculate the y-intercept? We substitute for x with 0, then we get y is equals to 4 over 0 minus 1 plus 2 is going to give me my y value as minus 2. So my set of coordinates for the y-intercept is going to be 0 minus 2, right? So which means before I draw my hyperbolic function graph, I first have to draw the lines of asymptotes. We determined them previously. We say the line of x is equals to 1. Here where x is equals to 1, we are going to draw a vertical line, right? It is this graph, right? Which I am just adding with my red like that, passing through your 1 like that. Right? And then my horizontal asymptote, we said is the line of y is equals to 2. Here it is. Right? So now here are my quadrants that are defined by the asymptotes. The first quadrant, second, third, and the fourth quadrant. And because my numerator 4 is greater than 0, I know that my graph is going to be in the first and the third quadrants. And now that I know my intercepts, I'm going to draw the correct shape. Remember, your graph, it gets very close to your asymptotes, but it doesn't touch or cross. So I'm going to draw a perfect sketch, cutting on the negative x-axis and passing through the negative y-axis or y-intercept. Gets very close to the asymptote, but it doesn't touch or cross. Same applies, I come to my first quadrant, draw a similar curve that does not touch or cross my line of asymptote, and it goes down, gets very close, but doesn't touch or cross my horizontal asymptote. That will be a neat sketch of my f of x, clearly showing our x-intercept at minus 1, 0, and our y-intercept at 0, minus 2. Now, you can clearly see, I wrote here, our basic function, the function of y is equals to a over x. And our a is 4 here, which is the graph of y is equals to 4 over x. It would be a graph that is around the axis like this. So we can all see that the basic function graph is shifted by 1 unit to the right and by 2 units upwards. What about 4.2.4? You are asked to determine the values of x for which 4 over x minus 1 is greater than or equal to minus 2. When you take your minus 2 to the left hand side of the inequality sign, it changes sign because this works just like an equal sign. It becomes plus 2, which means on the left hand side of the inequality sign, I'm having 4 over x minus 1 plus 2 is greater than or equal to 0. What is 4 over x minus 1 plus 2? That is your f of x. So in other words, they're asking you to determine the values of x for which f of x is greater, which is basically the region of your graph that is either at the x-axis or above the x-axis. So that will be this region where your graph is above the x-axis and your f of x is equal to 0 when it is cutting the x-axis, because this is our line of y is equals to 0. So how do we define this region as an inequality? It is the region of values of x that are less than or equal to minus 1, our x coordinate here. Right? No wonder I said x less than or equal to minus 1. Now remember, we are looking for values of x for which f of x is greater than or equal to 0. Where else do we find this graph above the x-axis? Here. And how do we write this as an inequality? Since it does not touch or cross the line of x is equals to 1, this is the values of x that are greater than 1. So my final solution will be x less than or equal to minus 1 for this region and x greater than 1 for this region. We are looking for the part of the graph that is above or at the x-axis. Then 4.2.5,